Today we are going to learn a solving method that uses the skill that we learned a week or so ago of completing the square. One of the nice things about this solving method is it works every single time. So we've learned how to solve by factoring, and we learned how to solve by taking square roots, and we said those are good methods. They usually work out decently clean, but they're not universal. You can't do them on every single quadratic. Completing the square can be done on every single quadratic, but sometimes it gets pretty disgusting. Most students, I'll just throw this out at the beginning, don't like this method. I've taught this course 8 years before this year, and in those 8 years, I've only ever had one student who this was their favorite method. Most students don't like this method, but it's an important skill to learn anyway because it is a universal way to be able to solve them. So our first step is to get the variables on one side and the constant number on the other. So I want any terms that have x to be on one side of this equation and any terms that don't have x to be on the other side of the equation. So that means I'm going to begin by adding 3 to both sides. And when I write it, I'm going to leave a blank where that 3 used to be. Step 2 then says if there's a coefficient of x squared, factor it out and divide both sides by it. So if there's a number in front of the x squared, we need to get rid of that number. You cannot complete the square with a number in front of the x squared. And this is where sometimes it can get kind of messy because we have to divide it out even if it doesn't divide into everything evenly. So we might end up with fractions then. This problem doesn't have anything in front of x squared, so we don't need to do that here. Step 3 is to find the special c value that makes it a special form and add that c value to both sides. Because whatever you do to an equation on one side, you have to do on the other side as well. We learned how to find the c value in the last portion of this unit. Does anybody remember how we found that c value?
B divided by 2 squared.
C is b divided by 2 squared. So in this problem, we would do 10 divided by 2, which is 5. Square it is 25. And that's what we want to add to both sides of this equation.
Wait, so you just did 10 over 2?
10 over 2 and then square it. So 10 divided by 2 is 5, square that is 25, and we add that to both sides of the equation to keep the equation balanced. Because the equation is a scale, and if I'm adding a weight of 25 to one side, I have to add a weight of 25 to the other side as well. Step 4 is then to factor, because this is now a special form. That's the reason why we add what we add, is because then this turns into a special form. It's the special form where we take the square root of the first thing, the sine of the middle, and the square root of the last thing squared. Equals, on the other side, add that together in 28.
Would plus 25 be the middle?
The middle is the plus 10x. So we square root of the x squared is x. We take the sine from the 10x, and then the square root of the 25. This is now something squared equals a number, which is what we learned to solve yesterday. So now we can solve this by square roots. So we're going to take the square root of both sides, which gives us x plus 5 equals plus or minus. Simplify square roots when possible. What's a perfect square that goes into 28?
4 and 7.
4 and 7. So this becomes 2 square roots of 7. And get x alone by subtracting 5 from both sides. So my final answer is x equals negative 5 plus and minus 2 square roots of 7. Okay, so first we get our letters on one side, numbers on the other. If there's something in front of the x squared, divide everything by it, even if it doesn't go in evenly. find the c value to add to both sides by b over 2 squared, and then solve as we did yesterday.
Can't you put the negative 5 with the 2, or does that not work?
You can't put it with the 2 because that is an order of operations thing. We have to do exponents in parentheses and then multiply before we add. And that 2 is times the square root of 7. So we can't do the adding. Okay, so on this one, we want to get our x stuff on one side and the number over on the other. So I'm going to begin by subtracting 12 from both sides. I leave a gap where that 12 used to be because we're going to add a special number in there. But before we do that, we must divide by something that's in front of the x squared. You cannot complete the square with a number in front of the x squared. So there's a 3 there, which means I need to divide every part of this problem by 3. X squared minus 2x blank equals negative 4. This is now set up to be able to complete the square. To complete the square, we take the middle number divided by 2 and square it. And that gives us what? 1. So I'm going to add 1 to both sides of this problem. You have to add it to both sides to keep the scale balanced.
The middle number is C.
The middle number is B. That 2 is B.
So
When I say middle, I'm just talking about one side of the equation. I'm not worrying about on the other side of the equation, but just on the left-hand side of the equation here. What's in front of x squared is A, what's in front of x is B, and we're finding the C value.
So, oh, never mind. I just answered my question.
Then we're ready to factor this, and it's a special form. So we take the square root of x squared, which is x, the sign of the b, which is negative, and the square root of that last number, which is 1. Squared equals negative 3. Then we're ready to solve by taking square roots. So I'm going to take a square root of both sides of this equation, which gives me x minus 1 equals plus or minus. 3 does not break down, but there's a negative inside of there. What did we say the square root of a negative was? An imaginary number. The square root of a negative is something we can't actually really do with our real numbers. So this is where that imaginary number comes from. So we're going to just, anytime we have a negative under a square root, we're going to pull it out and call it an I. Okay, I was the square root of negative 1. So we're going to take that negative out of there and call it an I. That's our imaginary number. Our final step, we want to get x alone. We're going to add 1 to both sides. And get 1 plus a minus square root of 3i.
What's the I there for again?
Because it was a square root of a negative number. And the square root of a negative number is imaginary. So we take the negative away and put an I instead. Right, what we're doing is like breaking it down just like we would simplify any other square root. But we're saying negative 3 is like 3 times negative 1. And the square root of negative 1 was how we defined I. So we're just changing that negative into an I. Right. First thing I want to do is get variable stuff on one side, constant on the other. So I'm going to add that 8 over to the other side. Then I check to see if there's anything in front of x squared. If so, I need to divide by it. There's not anything in front of x squared here, So I don't need to worry about that step on this one. Then I need to find my c value. To do that, we take b divided by 2 and square it. So that gives me what? Plus 9, and we add that to both sides. That is one of the biggest mistakes that students will make on these problems, is forgetting to add it to both sides. You have to add that 9 to both sides of the equation. Then we want to factor. It should now be a special form. That's why we added what we did. So we take the square root of x, the sine from 6x, and the square root of 9 squared equals 17. It grows. Hopefully it catches up. I did this last hour too, and like never woke up again. So I gotta wake up.
You said the answer was -3 plus or minus square root of 17.
I haven't said the answer yet, but yes, that will be the answer.
Sorry.
Rachel.
I thought you already said it and you were just
No,
waiting
I'm
for it
just-
to show up. And I didn't hear.
No, I'm just doing the factoring, but
How'd you get the parentheses x plus 3?
we take the square root of the first thing, the sine of the middle thing, and the square root of the last thing, and then there should be a squared here, which is here, but not there yet. So there we go. Okay, so that's what it looks like after we factor it. Then we're ready to take a square root of both sides, because a square root cancels that square. And I get x plus 3 equals plus or minus. And then we always want to think about breaking down a square root. So are there any perfect squares that go into 17? Nope, it's actually a prime number, so nothing goes into 17. And then we want to subtract 3 from both sides to get the x alone. So -3 plus or minus square root of 17. For this one, we want to start by getting our constants on the other side, leaving the variables where they are. I'm going to subtract that 30 over to the other side. Then, if there's a number in front of the x squared, you must divide everything by it, even if it does not go in evenly. On this problem, it does go in evenly to everything, but even if it doesn't, we still need to divide every term by it. Now we need to find our special value, which we find by taking b, dividing by 2, and squaring. That gives me plus 1 on both sides. We factor the square root of x squared is x, sine of -2x, let's see, square root of 1 is 1, squared equals -5. We take the square root of both sides. Square root cancels the square to leave x minus 1 equals plus or minus every time you take a square root. And that square root has a negative underneath it. So when we have a negative underneath our root, we're going to pull it out and call it I. And to get our x alone, we're going to add 1 to both sides. 1 plus or minus square root of 5, I. Questions? This one is already set up with variables on one side and constant on the other, so we're ready to just find our special c value. There's nothing in front of the x squared to worry about either. So we're going to do b over 2 and square it, which gives 4. So I'm going to begin by adding 4 to both sides of this, plugging in that special c value on both sides. They just saved us a little bit of work by having it already separated with variables on one side and constant on the other. Then we're going to factor square root of the x squared, sine of the 4x, square root of the 4 squared equals 3. And take a square root. Square root cancels the square to leave us with x plus 2 equals plus or minus every time we take a square root. And square root of 3 does not simplify and it's not negative, so we don't need to worry about the I. Then we're going to subtract 2 from both sides. We get negative 2 plus or minus square root of 3. Questions? I'm going to skip question 6 just for time. It's just like the last one that was already set up, so we're going to go on to question 7. Question 7 is not set up for us. What do we need to do?
Subtract 76.
Subtract 76 from both sides. X squared minus 16x, leave a blank, equals negative 76. Then we check to see if there's anything in front of x squared we need to divide by, but we don't on this one. So then we find our c value by taking b divided by 2 and squaring it. And what does that give us? 64. So we're going to add 64 to both sides of this.
Wait, wouldn't it be negative? Oh, wait.
We're squaring, so that always becomes positive. You'll always be adding c to both sides. So we factor square root of x squared is x. Negative from the negative 16x. Square root of 64 is 8 squared. Equals, combine that together, and we get negative 12 on the other side. Then we're ready to take a square root of both sides, which gives us an x minus 8 equals plus or minus every time we take a square root. Can 12 break down?
Yes.
Yes. To what?
4
and 3.
2 and square.
So that's going to become 2 and square root of 3, and it's a negative 12, which means we need an I. Okay, so sometimes you're going to need to simplify the square root for the number by looking for perfect squares that divide into it, but also every time there's a negative, turn that negative into an I. And finish it out, get x alone by adding 8 to both sides, but we can't actually add 8 to any part of it, so it just stays its own separate thing. 8 plus and minus 2 square root of 3i. Questions? On this one, our variables are on one side and constant is on the other, but we have something in front of the x squared, which you cannot have. So we are going to divide every term by 2. We get x squared plus 6x, and leave a blank, equals 2. If there is something in front of the x squared, you must divide everything by it as your first step.
Oh, you just answered it. You have to do it before you do the view.
Before you find your C value. Yep. So now we'll find our C value by doing b over 2 and squaring it. And that gives us 9 to add to both sides. Factor as x, square root of x squared, plus for the 6x, 3 is the square root of 9, squared equals 11. And take a square root. So I get x plus 3 equals plus or minus. Does 11 break down?
No.
11 prime, so it's just going to stay 11. It's not negative, so we don't need an I. We'll subtract 3 from both sides. I get x equals negative 3 plus or minus square root of 11. Questions? One more, and this is a good last problem because everything that could possibly happen is going to happen for us in this problem. So first thing we need to do, get the constant over on the other side. We begin by subtracting 93 from both sides. Next, I have something in front of the x squared, so I have to divide that out before I find my C value. Then I can find my C value by doing b divided by 2 and squaring it. And that gives me 4 to add to both sides of this. Factor x for square root of x squared minus for the 4x, 2 for the square root of 4 squared equals negative 27. And take a square root of both sides. And I get x minus 2 equals plus or minus. Does 27 break down? Yep. To what? 9 and 3? So that's 3 square roots of 3. And there's a negative there, so I need an I. Last step, add 2 to both sides, but we can't actually add it to any part. So we just do 2 plus a minus 3 square roots of 3, I. And that's our final answer. Questions? On your assignment, I'm not sure what your sheet says, but for what this says, I want to make an alteration and say that you can end at number 58 instead of number 60. If you are doing honors, 85.